Someone describe how you would shift the blue one to be over top of the red one. Yes, ma'am. You would slide it, and how, like what units would you slide it? How much right, how much left, how much down, how much up? Yes, sir.
You go down to the right side.
That's right. If you shifted this thing down 2 units and to the right 5 units, you'd be right over the top of it. Very good. That is what we're doing today. Mathematically, it's very simple. We're going to be doing things like that. We're going to take these coordinates and we're going to add 5 units to the x value and subtract 2 from the y value. Because isn't x horizontal and y vertical? Mathematically, what we're doing today is quite simple. It's the easiest thing we've done in this chapter by far. That's why it's kind of a nice... Now, it has nothing to do with anything that we've done so far in this chapter, but it's a nice kind of easy way to end it. However, there are several pieces of notes. The first piece, what we're going to be doing today are transformations of shapes. Now, you don't have to write all this stuff down. You don't have to write all this down. I'll let you know what's really important to write down. Everything I get from the book. A transformation is an operation that moves or changes a geometric figure in some way to produce a new figure. So in other words, we're going to start with some figure. This gave you an example of a triangle, although it won't always be a triangle. The Dom wasn't a triangle. And then we will do something to it, hence the arrow, to form a new image. So we're always going to have a pre-image, which is before we transform it in any way, and then an image. So in the Dom, the red was the pre-image, the blue was the image. Yes, sir. Yes, it is. Thank you. 4.8. Oh, I made one of those. I guess not. This is section 4.8. So a transformation is going to take a pre-image, change it in some way, and make an image. Transformations. We're just going to take some shapes, and yes, you're going to have to do some graphing today. Just about everything is on the coordinate plane. It's not going to be hard graphing, but you are going to do some graphing. Okay, here we go. Did you get that? The 3 main ones we're going to do are translations, reflections, and rotations. Now, actually, rotation we're not going to do hardly anything with, but I'm going to introduce it to you. And there may be a very simple test question about it, but nothing more. But those are the 3 we're going to deal with today, and they're very, very simple. A reflection. Jensen, what's a reflection?
When you look in the mirror and you see yourself.
Exactly. That's all it is. A reflection on a coordinate plane is instead of a mirror, you're going to have a shape, and it might be reflected over here, and you'll be able to tell because they'll look like the same thing, just kind of backwards from each other. That's all a reflection is going to be today as well. We'll look at examples of these if you're having trouble visualizing it. What's a rotation? Cameron, what's a rotation? Wow. That sounds all verbatim. Very good. That's right. You're going to take something where it's going to rotate it around a given point. So like the end of the minute hand around a clock is a rotation. And then the last one, the first one, translation is what we did in the DOM. It's like when you click and drag something on your computer desktop. When you take something and just move it without turning it or anything, that's a translation. And that's what you did in the DOM. So those are the 3 we're going to deal with. Translation and reflection are the ones we're really going to deal with. But I am going to introduce you to rotation. The reason we're not going to deal with rotations any more in depth is because the math to do a rotation is a little bit more complicated. But reflection and translation math is very straightforward. Alright, first things first. Here's what they'll look like. This is what a reflection would look like. You'll always be able to tell reflection because if you turn your head around the kind of line that it's reflecting around, it should look the exact same, obviously, instead of the different color. So if you kind of turn your head sideways, it just looks like the exact same thing, just flipped. That's a reflection. Rotation. At any point today, if you can tell that your shape has been turned, then it'll have to be a rotation. So you see how this is just rotating around? Rotation. And translation will look literally the exact same, just shifted. Just shifted. Now let me ask you this. Let's say we didn't know that was a translation, and they said, here's a line. How do we know that's a translation and not a reflection? Somebody raise your hand and tell me. How do I know that's a translation and not a reflection? Elon. How do I know? There's no like vocabulary you're using. You just use logic. How could I determine that this is a translation and not a reflection? Exactly. Very good. Reflections will look opposite around that line. Translations will look the exact same. Very good. Okay. Congruence transformation. You don't have to write this down because everything we're doing today is a congruence transformation. Basically, guess what? You have these context clues. They're transformation with congruent pieces. In other words, your pre-image is congruent to your image. They're all going to be like that today. If at any point today, your pre-image is not exactly the same as your image, just turned or flipped or something, then you've done something wrong. They're all three of these are congruence transformations. Okay. Let's see. Translations. All you need from this is this. You need to write the word translation and then this formula. Translation. That's really all you need. Write translation and then write that little formula. And it's just as simple as Tripp described in the DOM. However much you shift, that's what your A and B values are. That's what you're adding or subtracting, depending on if you're going up or down or left or right. Yeah, I get every bit of this straight from the textbook. But rather than say, hey, everybody look at the textbook, I just blow it up big up here. It was. In fact, the next example is the DOM, but it's the actual book version of it, where it says the math that was involved. Yes, the DOM was definitely a translation. So however much you're shifting is what's going to determine your A and B values. Now, the DOM, help me remember. Did it shift left or right? Now, think of the coordinate plane. Is right positive or negative? It's positive. And how much right did it shift? Do you remember? So that would be x plus 5. And then did it go up or down? What do you think that's going to be? Negative or positive? So that's going to be y minus 2. And that's all translations are. That's it. In fact, here was the DOM. Here was the DOM, and here was the official. If I had asked you for the new coordinates, all you'd have to do. Now, sometimes today they'll give you the formula. They'll say, hey, here's the translation formula, or however they'll word it. And they'll say, here are your vertices, find your new vertices. Half the time you won't be asked to graph it today. You'll just be asked for the new vertices. Well, you just take all your coordinates and apply this. Negative 4 plus 5, 1. 3 minus 2 is 1. There's that coordinate. Negative 2 plus 5, 4 minus 2. There's that coordinate. These are just these plugged into that formula. And then you can see how it affects your graph right there. There are going to be some you're asked to graph, but not all of them. Are there any questions about where they got anything that you see on the screen? Sometimes, just like the DOM, it won't give you the translation. It'll say, here's 2 sets of coordinates, or here's an image. Describe the translation. So you'll have to say, oh, write 5 down 2, just like you did in the DOM. Okay, let's see. A reflection. Now, all you probably need to write around this is reflection in the x-axis is this formula. Reflection in the y-axis is this formula. There are 2 different ones. X-axis and y-axis are different. That's the only 2 things you're going to be asked to reflect around in this chapter. And it's quite simple. If you flip around the x-axis, you use that first formula. If you reflect on the y-axis, you use the second formula. Everybody need me to leave that up there? Okay. Rotations, we're really not going to talk about them. The only thing you really need to know about a rotation is the center. It'll always go around some central point. But again, we're not even going to really deal with rotations. We're just going to skip it. Okay. A, what is it? Somebody raise your hand and tell me. Which of the three transformations is it? Stacy. Very good. Is rotation. Anything with a turned arrow. B, what is B? Malik. It is reflection. And Amber, what's C? Very good. Translation. So, now that you can recognize them, let's see. Triangle ABC has those three vertices. Sketch triangle ABC and its image after the given reflection, and then B after the given, translation, then reflection. Okay. So, this is two separate problems. Yes, you're going to be asked to graph today. Darn it, I did not boot up my board. But we're going to do this again. I do. I'll hand that out when time comes. Or actually, I'll just leave it up here. People who want it can take it. Although you don't have to be like precise with this. Okay. Let me make these smaller so I can fit my graph on the board. Okay. Coordinate plane time. So here's what you're going to have to do. First things first. Alright. Plot your points. A is 3, 5. Three, 5. That's point A. B is 4, 2. Approximately right there. And C is 1, 0. I'm really looking for the general shape here, okay? It doesn't have to be perfect. If I see this general shape, that will be fine. Now, first thing, translation. There's two ways you can do this. You can actually just write out your new coordinates and then just plot them. For instance, A, we have to do -4 plus 1. 3 minus 4 is what? -1. 5 plus 1? 6. 4 minus 4? 0. 2 plus 1? 1 minus 4? 0 plus 1? 1. Now, that's one way you can do it. Just find your new coordinates and plot them. There's -1, 6. Here's 0, 3. And here's -3, 1. And when you connect your dots, you should see the transformation-ish. Now, mine looks a little bigger because I didn't draw it perfectly. It should be the exact same. Or, of course, another thing you could do is just like, hey, I'm going left 4, up 1. Left 4, up 1, plot a point. Left 4, up 1, plot a point. Left 4, up 1, plot a point, connect your dots. That's another way you can do it. Now, for the reflection. Now, reflection in the y-axis. On your notes, it said, if you're going around the y-axis, for your original xy, what was your new coordinate? Was it x negative y, or it was x? It was negative xy? Make sure you look at that in your notes. Around the y-axis, so what's the difference between this point and this point? The x is negative, that's it. Or if it was, well, yes. So, our new coordinates. I'm just going to take these exact same ones, except make the x the opposite sign. So that'll be -3, 5, -4, 2, and -1, 0. Now, what if they had already been negative? What do you think I would do then? Exactly, just change the sign. So -3, 5. Let's see, -4, 2, and -1, 0. Plots your points, and hopefully you can see that that is a reflection from the other side. Now, again, I didn't draw it perfectly, but. And you can draw all these on the same axis today, okay? Even though yours will all be in pencil, not color-coded, I get it. If I see 3 pencil triangles like this, I'll get that that's what that was. You don't have to do a different graph for every single one of them. Questions about how we got those points and how we graphed them? Great. Where you are, try this one. I'll come around and look. This should have been your original after you just plot the original 4 points. How? How'd you do it? Did you get the X and Y's backwards? Ah. Well, now this is just the example. You don't have to erase anything. Just remember that on the homework. Okay. Part 2. What you probably should have done. The easiest way to do this, make your new coordinates. And here's how the book often does it. Your new A, B, C, and D will be A prime, B prime, C prime, and D prime. And that's going to be these coordinates. Now, easiest way to do it is do all the X's at once and all the Y's at once. So we're adding 6 to the X values. What's negative 5 plus 6? 1. What's negative 1 plus 6? 5, that's right. What is negative 3 plus 6? What is negative 5 plus 6? 1. Now let's do all of our Y values. What is 5 minus 2? 3. What is 2 minus 2? What is 0 minus 2? And 0 minus 2 again is still negative 2. So now we're ready for our translation matrix. 1, what's that? Yes, 5, 0. 5, 0. 3, negative 2. And 1, negative 2. Connect your dots. Now again, mine don't look the exact same because I'm human and make errors, but it should be the same exact shape, shifted right 6, down 2. Ish. Now when you have graph paper, if you choose to use it, it'll be a little easier to keep up with that. Now, reflection. Madison, in your notes, reflection in the x-axis. What does that do to our coordinates? If we start with xy, what's our new coordinate? For the x-axis? X, negative y. There you go. It's important to keep those different. For the x-axis, it's just x, negative y. So once again, we're just going to come up with our 4 new coordinates. What do you mean? That was in the notes. That was on right here. Or actually, it'd be up here for you. That was really the only important thing to take away from this, was that in the x-axis, that's going to change your coordinate to this. In the y-axis, it's going to change your coordinate to this. Now, this is in your book. This is in section 4.8, so if you didn't get it, you might want to go get it from there in a bit. So anyway, here we go. So what's the only thing that's changing? Yeah. That's right, but which one of them is changing? The y. We're just going to change the sign. So all the x's are staying the exact same. So it'd be negative 1, negative 3, and negative 5. None of the x's are changing. Only thing that's changing are the y values, and we're changing their sign. So that'll be negative 5. Sorry, I don't know why I did this so small. Negative 5, bless you. Negative 2, bless you again. Negative 0, which of course is just 0, and negative 0 again. That's exactly what we do. So, negative 5, negative 5. Negative 1, negative 2. Yes, ma'am. Yes. It is. I didn't draw it very well. It's negative 1, negative 2. Good catch. Negative 1, negative 2, negative 3, 0, and negative 5, 0. Yes, sir. Do you understand where this came from? Exactly. Well, that's all we did. This is the formula for a reflection in the x-axis. So, we looked at that formula, saw that the only thing we were changing were the y values. And so all I did was take all the original x values, -5, -1, -3, and -5, and I changed all the y values to negative. So -5, -2, 0, and 0. Elon, the trick every time will be, it'll tell you reflection in which axis. And then you have to look at your notes and figure out, well, does that mean you're changing the x or the y? Well, in this one, we were changing the y values. So that's all I did was change the y values in my original. Now, if you plot the points, hopefully, if your drawing is even a little bit accurate, you can kind of see the reflection around the x-axis. Questions? Yes, sir. The red ones? We applied, that was for this part, we did this to every coordinate. We added 6 to the x value, so -5 plus 6 was 1. Then we did this to every y value. 5 minus 2 is 3. And we did that for every single point. Okay? Questions on any part of this problem or what you're going to be asked to do? Well, there's only one more slide, and it doesn't even require graphing, I don't think. Anybody need me to leave this up there? Okay. The next slide will say something like, hey, if you're shifting 4 left and 3 down, what will that look like in math terms? So you're going to have to translate that. X plus 3, y minus 4, that kind of thing. So, actually, we can probably just do this verbally. Hey, Rachel, if I said you were going 2 left and 3 up, what do you think that would be? 2 left would be what? Well, we're shifting. So, left, is that x or y? X. Left is negative or positive? If you're going left on the coordinate plane, is that negative or positive? Right's positive. Left is negative. So that would be like x minus 2, for instance. So that's what we're going to be doing on this one. 4 units left, 2 units down. So they're all going to be of this form. They're all going to be x plus or minus something, y plus or minus something. Blake, what's the first one? Very good. Left means you're going left minus 4 units. Down means you're going minus 2 units. Whereas right or and up would be plus plus. Let's see. Just me. What would number 15 be? Sorry. It's not x equals. It's x. X plus 2? Yes. 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 X plus 2 and then what with y? Justin, help her out. What's this going to look like? X plus 2, y minus 1. That's what you're going to be asked to do on that portion of your homework. Yes. There you go. The only portion that's even is the part that it says it's even. Everything else is verbatim.